Bonsoir. My name is Eli Birstein. I work at Google where I lead the anti-abuse team. And today, with the help of Kylie and Luca, we're going to tell you about tracing ransomware payment end-to-end. A few weeks back, we ran a consumer survey to figure out how many people were backupping their data on a regular basis. As you can see on the slide, the results are not really good. Only 37% of the survey respondents did back up their data, which leave a lot of people open up to ransomware attacks as they don't have backup of their precious file. This is why it is not surprising that ransomware have dominated the press over the last 2 years, making regular headlines about massive infections. Similarly, at the Google search level, we did see an increase across 10x of the search query related to ransomware over the last 2 years. So one has to wonder if ransomware is here to stay, or is it just a hype and it's just in the press? To understand better how sustainable is ransomware and how profitable it is for bad guys, we set out to run a study to trace the money and see how much they were making. The talk today is a story about this research. We're going to go through 3 points. First, Luca will tell you about how we trace ransom, what is the methodology so you can do it as well. Then I will give you a brief overview of the insight we gathered thanks to the data we collected. And finally, Kylie will give you a few case studies of who are the kingpin and the fad in this ecosystem. Before getting started, it is important to say that we could never have done this study on our own. We were able to gather a lot of great people to help us out on the journey to understand better how ransomware are making money, and that way help understand better who we should prioritize our protection to protect better our users against those threats. We worked closely with Chain Analysis, a startup dedicated to Bitcoin tracing at the University of San Diego and the University of New York. Luca is now going to tell you a little bit about how the life of a ransomware infection.
Hi everybody, my name is Luca and I'm a research scientist at Google. To understand how we trace ransomware transactions, we first have to take a look at how the typical ransomware infection looks like. Ransomware is distributed much like any other malware to a combination of spam messages, infected websites, and attacking directly services that are exposed on the local network. Once ransomware gets execution on the victim machine, within a couple of minutes it encrypts all files that it deems important to the user, such as photos or Word document, and then it displays a ransom note to the user telling them, hey, I've encrypted all your files, but you can get them back if you pay me. Typically, this payment is in Bitcoin, the cryptocurrency. And additionally, they add the next step, which is a payment URL the victim should visit in order to see how to pay. This is how the typical payment website looks like. They are hosted in Tor to make it hard to take down. They go through a detailed explanation on how to purchase Bitcoin and where, and then they give the victim a unique Bitcoin wallet so that they can pay. The ransomware author does so they can trace directly in the blockchain, in the Bitcoin transaction network, who paid and who didn't, so that they can release the file to the right person. Finally, the victim goes to a Bitcoin exchange. This is just a place where you can sell your state-issued currency to acquire Bitcoin so they can pay the ransom. Now, why do cybercriminals all seem to be using Bitcoins for this kind of crime? This is because Bitcoins are advantageous in several ways. First of all, it's easy to create wallets. You can create many of them, and you don't need to show any kind of ID. So this allows to automate the process. Additionally, all transactions are irrefutable. This is different from credit card where you can dispute a charge. And finally, it's very easy to convert cash to Bitcoin and back because of the high volume of transactions that are happening right now. So this is how a Bitcoin transaction looks like. All Bitcoin transactions are public, and this allows us to follow how the money moves through the Bitcoin network just by looking at the transactions. We just have a sender, a receiver, a transaction ID, a date, and an amount. And this particular transaction is a victim of the lucky ransomware paying the ransom. So once the victim purchases the Bitcoin and pays the ransom, the cybercriminal takes over and moves the ransom amount in Bitcoins through a series of wallets to try to make it harder for us to trace them. Eventually, though, all the ransom amount ends up in a cybercriminal controlled accumulation wallet. This is where multiple victims' ransoms get accumulated by the cybercriminal. And periodically, the cybercriminal takes the money out from the Bitcoin network by going to an exchange, selling the Bitcoins, and getting back cash. So now that we have seen exactly how a ransomware infection works and how the victim pays, we can use this to measure the revenue. The key part is the accumulation wallet that the cybercriminal controls, where all the victim transactions end up into. If we can't identify this wallet, then we can look at the Bitcoin transaction ledger, look back in time and discover other victims that have paid in the same wallet. So these are all ransom victims. So it's critical for us to uncover these accumulation wallets. We do so by having seed Bitcoin transactions of ransom payments. And we collect these in two ways. One, we scour the internet to find victim reports. So people that have said, hey, I've been infected, I've paid, this is the Bitcoin I've paid. These are great because they're very stealthy. The ransomware author can't know we are looking at what they're doing, but they're far in between. So in order to complement those, we act as synthetic victims. We infect our own virtual machines, and we use machine learning to extract the payment information. And finally, we can make microtransactions to pay small amounts to the Bitcoin wallet that we discover to uncover more of the ransom payment network. In order to have a more complete coverage of ransomware, we also need to collect a large amount of binaries that we can execute. We start off with an initial seed of ransomware where we have high confidence labels that identify the binary and the family of ransomware. And we apply machine learning to expand this data set and to cluster it into family and variants. Then we select a few samples from each family and variant of ransomware. We extract via machine vision the payment information, and finally we can perform these microtransactions. This is the initial data set we were working with. It comprises of 34 families and 100,500 binaries. We take all of these binaries and we use code similarity to find additional binaries that share some code structures with the ones that we know are ransomware, and we add them to the data set that we're looking at. And then we execute all of these and we look at the domains they're contacting to see if they are part of the same family. On top of this, we apply clustering to identify the families and variants of ransomware. Thanks to this, we can now select a few samples, execute them, and extract the payment information. The total number of binaries that we're working with now is about double the initial one, 300,000. So finally, we can apply machine vision, extract the payment information, such as you can see here. We have the payment side at the Bitcoin wallet, the victim, which is us, is supposed to pay. By making these micropayments to these wallets, we can finally discover the graph that shows the ransomware payment structure. We have, here is a simplification of this graph, it's just a part of it, but we have 3 ransomware families, and we can see where the victim purchased the Bitcoins, in which exchange they did, and where the ransomware author is cashing out the Bitcoins to get money out of the system. So for more on this, I'll give the mic back to Ellie.
All right, so after we've done all this hard work, who took months, we finally got enough data to paint a picture about how big is the ransomware market. I guess that's why you all are here, so what did we find? First and foremost, we found that overall, at least $25 million were made by ransomware authors. This is a low bound number, meaning that these are the transactions we can directly attribute to ransom payment. So there are many others we might have missed, but those are the ones we can directly attribute. And for us, it was very important to have a rigorous study where we can actually pinpoint and explain everything we have computed, because it has been in the past as you all know, quite a few random numbers thrown around in the cybersecurity world, and we wanted to have something which was grounded in data. For example, if you're interested in looking at the data yourself, please reach out to us. We'll gladly share with you the list of transactions so you can reproduce our experiment and fully help us to understand better even the ransomware world. Let's break down this number into a few ways so we can gather some insight. First, let's break it down by year and by month. The thing we do see is indeed 2016 was a turning point. This is a year where ransomware became a multi-dollar business. This is the first time ever ransomware were able to accumulate more than $1 million in ransom on a given month, and it became a very, very profitable market. And so based on this insight, we are fairly certain that ransomware is here to stay, and it will be with us for quite a long time due to its ability to return a lot of profit to malware authors. Breaking it down by family, two kingpin emerge. The first one is Lucky, who topped at $7.8 million of revenue, followed closely by Cerber, which is at $6.9 million. We do expect by the end of the year that there will be a switch, and Cerber will become the most profitable ransomware in history due to its as it's very active still today. And then we have a few up and running upcomers. For example, Samsung, which recently emerged in 2017, and is already at $2 million. And then of all the other family, very few made over $1 million. So as you can see, as many of the mature market, we have a 80% low, which is again verified. The biggest actor makes most of the revenue. Breaking down by family and by year, we clearly see that ransomware is a fast changing market, where the kingpin of 2016, Lucky, has been replaced by the 2017 kingpin, which is Cerber. But there is also aggressive competition at the moment for Cerber coming up. Most of it comes from Samsung and Spora, which are also making a dent into the market. So a very, very fragmented market in 2017, many newcomers, and again, a lot of revenue. So we expect this trend to keep going. One of the interesting shifts we did observe over the last year was the diversity of binary. Until 2017, ransomware used very few binary, which were heavily distributed and accumulated a lot of revenue. Starting in 2017, we see a lot of binaries with far few revenue. We believe this is an attempt to evade AV by diversifying the attempt of obfuscation, but also the rise of affiliates. Looking at where the victims buy Bitcoin, most of them buy them from their friendly neighborhood, so what we call the Craigslist of Bitcoin. It's called local Bitcoin, so you can buy them from someone in your city who have them, probably because it alleviates the anxiety or the complexity of buying Bitcoin if you're not familiar with it. Most people who are a victim of ransomware are not very familiar with Bitcoin, so maybe having a friendly first helps them getting started. The rest is basically bought from the normal Bitcoin exchange that everyone uses, at least in that community. Looking at victim payment, 90% of the transaction goes well, and then we have 9% of people who have to pay more than once. So the reason for that is some ransomware family are very strict on the amount of money they want to receive. Some of them are more flexible, but the ones who really want an exact amount usually make people pay twice because they discount the fee that you have to pay every time you do a transaction in Bitcoin. A fee incurs, and people might have just bought the exact amount they wanted, and so forgot to account for the fee and have to buy more time. We also observe a very, very small amount of people who are paying multiple times, and we're not sure why, but we did occur and see that in our data set. Finally, the last insight we have is where the money is flowing out. So where bad guys are cashing out, 95% of the cash out are through BitC. And today, actually, it was announced that one of the allegedly founder of BitC has been indicted for money laundering for over $4 billion. So it's interesting. There is kind of correlation between the arrest and what type of money is going through this exchange. This exchange has been located in Russia. Again, if you're interested in knowing the list of cash-out wallets, we're happy to share. Just go talk to us after the talk. And now I'm going to let Kylie tell you a little bit about who are the interesting facts about our case studies.
Hey everyone, I'm Kylie and I'm an analyst on Safe Browsing. As Ellie mentioned, last year was really a turning point for ransomware, and in part that was largely heavily influenced by one particular ransomware family, and that was Locky. So we saw Locky really dominate the press last year, and we saw ransomware infections started to surge, and in particular we started to see key infrastructure like hospitals be targeted. After a brief break earlier this year, we saw Locky re-emerge, albeit at much lower levels than what we had seen previously. Now, one of the most important things about Locky as a ransomware family to us is that it was the first family to make over $1 million in revenue per month. And that really highlighted the fact that ransomware is truly profitable for cyber criminals. And one of the key aspects of Locky is its use of cyber criminal infrastructure to distribute its ransomware. And that really allowed the authors to instead focus on developing and iterating on the ransomware itself. So for example, Locky's previously used the Nakurs botnet to distribute its ransomware via spam email campaigns. Later, we saw some of the newer ransomwares like Cerber recognizing the usefulness of similarly renting out cybercriminal infrastructure and instead focusing on the code. And as Ellie mentioned, earlier this year we had a turning point and we saw Cerber become the new king of the hill as far as ransomware is concerned. Now, though it's not the only ransomware family to do so, we think that Cerber's successful use of using the ransomware as a service model has really highlighted the fact that this isn't a game anymore that's just reserved for tech-savvy cyber criminals. It's something which anyone can get involved with. By using this affiliate model, Cerber's been able to achieve something that actually very few ransomware families have been able to do, and that's been able to sustain a consistently high income. So you can see from the graph here, we've seen Cerber making over $200,000 a month now for over a year. By intercepting Cerber's telemetry, we've been able to take a closer look at its affiliate model. And something that we've found is that in general, there's only a few affiliates that tend to make up the majority of Cerber's revenue, as well as account for the majority of its victims. So in a 2-week period that this graph covers, you can see that there are 8 affiliates responsible for over 50% of the infections. And then a very long tail of affiliates who are only responsible for a small handful of victims each. Another interesting aspect of Cerber is its domain generation algorithm, whereby it actually uses the blockchain as its DGA. So Cerber had hard-coded wallets that transacted periodically with new wallets, and then Cerber derived its ransom sites from taking the first few letters and numbers of those wallets. Taking a closer look at the telemetry for Cerber, one of the other really interesting things that we found was that on average it took less than a minute for Cerber to encrypt all of the victim's files. Now for us, that really emphasizes the fact that once infected, it's actually really difficult for a human to respond quickly enough to actually mitigate the impact of this type of threat. We'll take a really quick look at a couple of the newer ransomware families, starting with Spora. Now what's really interesting about Spora is its redefined business model. So we saw Spora trying to improve the user experience, if we can call it that, for the poor victims who are engaging with it. But nonetheless, by using things like real-time chat and offering its victims a range of payment methods, choosing from things like immunity or full restore, all the way through to individual file encryption, we saw Spora try to increase its conversion rate using this new type of business model. More recently, we've seen the rise of ransomware imposters. So here's an example of WannaCry, which we think disguising itself as ransomware by displaying ransom notes. We actually think it raises a lot of debate over whether this type of malware was actually designed to be more of a wipeware than a ransomware. So in this case, by having victims only transact with a handful of hard-coded wallets, it was extremely difficult for the ransomware authors to actually trace payment sources. So it was going to be very difficult, even if a victim paid, to make sure that your files were even decrypted. Nonetheless, we saw WannaCry really dominate the press. So it became infamous for its use of the Eternal Blue exploit, leaked from NSA, as well as targeting key infrastructure from hospitals through to traffic cameras. Luckily, despite all that press, very few victims actually paid, and even those that did pay, we haven't seen the WannaCry authors actually cash out that money. Taking a look at the Bitcoin wallets associated with WannaCry, we actually saw them active about a month and a half from March before the actual outbreak of the ransomware, and we think this is possibly associated with the testing period for the malware. Once it was released, you can see the sharp increase in payments, but luckily, following a lot of press reporting about the inability of them to actually decrypt your files, we did see a decrease in payments. But what was interesting is if you look at that orange line, even once the payments decreased, we continue to see an increase in the number of unique binaries associated with this ransomware being distributed. Most recently, we had the rise of NotPetya, again, which we see more as a wipeware rather than a ransomware. Unlike WannaCry though, we didn't actually see any use of the Bitcoin wallets associated with NotPetya before the ransomware was released, but nonetheless, we did see about 35 people still unfortunately paid. Luckily, there was a sharp decrease after there was a lot of press coverage. You can see a couple of remainder payments there that were quite low, but unfortunately, fortunately, we think they're probably more just associated with researchers. But what's really interesting about NotPetya, unlike WannaCry, these authors actually cashed out the ransom payments that they received. So a few takeaways we'd like you to have. As we've shown, ransomware is a multi-million-dollar market. So we should all expect this to be a sustained threat that we all need to be taking into account, whether you work for a small startup or a large multinational corporation. We also expect the use of this ransomware as a service model to increase following Cerber's successful use of it. And now that's going to increase the number of actors who are involved in ransomware, as well as increase the complexity for us when we're trying to fight it. And lastly, we see the attribution of this malware becoming increasingly complicated with the rise of wipeware, leading to increased disappointment when victims pay ransoms only discover that the malware authors either can't or won't, never intended to, actually decrypt their files. We'd like to thank you all for coming today. We'd really appreciate any feedback you have, so if you could take a couple of minutes to fill out your evaluation forms, that'd be fantastic. And tomorrow, Google's presenting on attacking encrypted USB keys, and we'd love to see you all there. Thank you.